So here's a run through of the extra practice problems that we have as part of the 10-4 lesson. So again, mixed review. So this is going to be mixing and matching arithmetic and geometric problems, as well as a couple application problems, some word problems in here. So first one, let's just go straight out at, figuring out each possible thing we could about each type of sequence. So we've got actually 6 things we're going to figure out about each sequence that's given. We need to write the next 3 terms. And kind of in that, in that step, we'll be deciding the second piece, is it an arithmetic or geometric sequence? We need to find out what our common difference or ratio is, write a recursive rule, our exponent or explicit rule, and we're also going to find the 8th term, a sub 8. So some of these steps, again, we're going to kind of be doing these all together as we're trying to understand each sequence. So our first sequence, we have 12 to 13.5 to 15. So let's see here. So we could possibly be multiplying, but I always like to check the arithmetic difference first. So let's try subtracting. So if I subtract 13.5 minus 12, I actually get 1.5. So if I add 1.5 to 13.5, that does give me to 15. So that means my common difference is actually 1.5. And that verifies because if I tried out that rule from the first to the second term, and then I tested it on the second to third term, then I know that has to be arithmetic. So to find the next 3 terms in the sequence, I would just have to add that value. So 15 plus 1.5 gives me 16.5, plus another 1.5, plus another 1.5. So there's our next 3 terms. And we're definitely using this as an arithmetic sequence. So it is an arithmetic pattern. Our difference, our common difference or common ratio. Well, for arithmetic, it's always a common difference. What do we add or subtract? Now, we need to write our recursive rule and our explicit rule. So recursive rule was always based off the previous value. So all we need to do is state the difference. So a sub n equals a sub n minus 1, the previous term, plus 1.5. Now we've got to fill in more info for our explicit rule, which is we take our first term, which in this case was 12, and then we're adding n minus 1 and multiplying it times our common difference, 1.5. And again, we could absolutely simplify that out so we don't have quite so many terms with the multiplication, but either one's fine to leave it. I know there's not a whole lot of room in the organizer. And then our last one is to find a sub 8. So I'm going to go ahead and use the explicit expression, the explicit formula that we found in part E, and just plug in. So 12 plus 8 minus 1 times my 1.5, aka that's going to be a 7. 7 times 1.5, and then add 12 to that. You could probably just put that in your calculator all in one line. Just be very careful and make sure you're coming out to 22.5. So likelihood is the next one is a geometric sequence. And the other thing that kind of gives it away for me on this one is you'll notice we're flip-flopping between positive and negative values on this one. So I know whatever I'm going to multiply with my common ratio, that it is going to be negative. And so how do I get from a 1200 to a 600 and then to a 300? I'm getting smaller. So that means you're probably going to be dividing by something or multiplying by fraction. 600 is how much of 1200? Well, that's just half. And again, what I would probably do for the math behind it is take your second term and divide it by the first term. So 600 divided by negative 1200. My zeros actually cancel out. And if I simplify that down, that actually simplifies down to 1/2. So that is my common ratio. So to find the next terms, again, just keep multiplying by that. So negative 300 times negative 1/2 is positive 150 times another negative 1/2, negative 75 times another negative 1/2, positive 37.5. And the values, again, they keep flip-flopping back and forth between positive and negative. We definitely use this as a geometric sequence. Our common ratio that we multiplied by was negative 1/2. And so again, recursive formula just says, hey, keep multiplying by that negative 1/2. So a sub n equals a sub n minus 1 times a negative 1/2 or negative 0.5. Really doesn't matter how you write it. Our explicit formula, which again is just based on the a sub 1, so that's negative 1200 times the negative 1/2 raised to the n minus 1. And for our a sub 8, so 8th term, plug in 8 for the n. So up in the exponent 8 minus 1, that's going to turn it into a 7. So this is really 1200 times negative 1/2 raised to the 7. And again, be careful, TI calculator, use the parentheses. You should get out 9.375. Again, as you go on in the sequence, because we're multiplying by a number that's smaller, the absolute value is smaller than 1, we're just going to get closer and closer to 0 as we go in on that sequence. Alrighty, next examples, find the arithmetic means. So again, find your missing terms. Check your number of steps. So 1, 2, 3, 4 steps. And I know this is arithmetic, so I'm just dividing up those differences to see how much I'd use at each step. So 48 divided by 12 is going to give me, 48 minus 12 gives me 36. And so that 36 divided up amongst 4 steps is going to give me a plus 9. So I need to add a 9 to each value to get the next one. So that's going to give me 12 plus 9 is 21, plus another 9 is 30, plus another 9, 39. Okay, do the same thing with part B. So 1, 2, 3, 4, 5 steps on this one. We started at 50, wait a second. We started at 50 and ended at 50, started at 75. So if I subtract those out same order, I'm actually going to get a negative number. So negative 25, and negative 25 divided amongst the 5 steps, I get a negative 5. So let's think about that. That means that I'm subtracting 5 at each step, which makes sense. If you start at 75 going down to 50, you've got to subtract at each step. So we're going minus 5 at each stage. So 70, 65, 60, 65, 55, and 55 minus 5 gets us to that last 50. Alrighty. Do the same thing with geometric means. So again, with these, we need to make sure that we are figuring out what our common ratio is. We don't do this the same way. We're actually going to use our formula, which again was a sub n equals a sub 1 r raised to the n minus 1. We know these values, so let's use them. So a sub n and a sub 1, and we know we have 1, 2, 3, 4 steps, so n equals 4. Solve out your equation. So 1/3 equals 27 r raised to the n minus 1, which is 3. Divide both sides by 27. You're actually going to get 1 over 81. And again, I like leaving these as a fraction because I can recognize this pattern a little bit. 81 is what value cubed? That's 3. I would not have been able to recognize that if I change it over to a decimal. So sometimes leaving things in fraction form can help you out. So divide each one by 3. So 27 divided by 3 is 9, divide by 3, divide by 3. 1 divided by 3 gets us that 1/3 at the end. Okay, part B. So same thing. We've got 1, 2, 3, 4, 5 steps. So n equals 5. We ended with 64. We started with 2, and we have n minus 1, so r raised to the 4th power. All right, divide by 2 gives me 32. What number raised to the 4th power gives you 32? Or take the 4th root on your calculator. So r equals 2. So multiply by 2 at each stage. So 2 times 2 is 4, times 2, 8, times 2, times 2, 32 times 2 is 64. We got it. Okay, find the sum of each described sequence. So again, I would go ahead, pause and write this down because I'm about to flip over to my Desmos calculator. Alrighty, so let's plug these in. Let me change over to my web browser. There we go. So again, to get our summation in there, let me delete that out. Two ways we could do that. You could go to Functions under the Miscellaneous menu and hit the summation button right above midpoint. Or you could, from your keyboard, just type in sum and the calculator knows what you're trying to do. So for number 11, it already has it in n, so let's leave it with that n variable. So we're starting at 1, and then the top of our summation said 6, so we're doing the summation of the first 6 terms. Our equation is 3 times 2, and I'm going to type it in exactly the way it looks, raised to the n. And again, I don't have the n variable, but go back to your, you can type it in on your keyboard or go back to the ABC screen and hit n. There we go, 378 for 11a. Alrighty, so all we need to do is tweak this for part B, but you'll notice the variable changed. So now we have a k equals 1 down at the bottom. So let's go ahead and type in a second one. Oops, there's some. But we've got to change our variable to k. Or we could just keep everything as an n, but I like to type it in as exact as possible. You know, fewer things for me to, miscopy. So k is starting at 1 and going up to 25. So the sum of the first 25 terms. And we have our formula, parentheses, 7k. So again, back to the keyboard, k plus 2. And the reason I'm having to use the keyboard, again, I'm using a touchscreen computer. So any of you that might be using a tablet, that's how you're going to access it. So that's going to be your answers for number 11. So let me switch back over and write those answers down. Okay, so number 11, we got out 378. 11B, we got out 2325. Alrighty, so numbers 12 through 14, we're going to find S sub infinity if possible, and if not, state why. So again, S sub infinity means as we keep going, our terms get smaller and smaller and smaller and smaller, but what R value would prevent that from happening? Yeah, anything that has an absolute value of greater than 1. So we have to look at only fractions. So that means we can do this with number 12. That'll work okay. How about number 13? Are the values getting smaller and smaller and smaller? Nope. So numbers are getting bigger. So our absolute value is greater than 1, so this one won't work. What about 14? Are the numbers getting closer and closer to 0? Yep, so we can only do 12 and 14. So our formula, S sub infinity equals a sub 1 over 1 minus r. That's it. So all we have to do is plug in. So 1 over 1 minus 2/3, aka 1 over 1/3. But what happens when you divide a fraction? It's the same thing as multiplying by its reciprocal, and the reciprocal of 1/3 rather, is 3. Now, for number 14, they don't just straight out give us the values. We know that 54 is a sub 1, but what do we have to multiply to get to the next number? And then the next one, and then the next one. So again, I would suggest do second term divided by first term if you can't see the pattern. So negative 18 divided by 54, that's giving me negative 3 or negative 0.3 repeating, which if I change to a fraction is negative 1/3 is my multiplier. So S sub infinity equals 54 divided by 1 minus negative 1/3, which is really 1 plus 1/3 or plus 4/3, or 1.3 repeating, which I could do it that way, or I could do 54 times 3/4. Either way that you plug it in, however you choose to do that on your calculator, you should get 40.5. 5. Alrighty, then a couple word problems. Here we go. So a new car cost Tracy $32,500. He knows that it will depreciate at 15% each year, which is pretty accurate. If he wants to sell the car after owning it for 5 years, what price can he expect to pay? For your hint, A sub 1 is our initial cost and A sub 2 is the cost after 1 year. So after owning it for 5 years, what's our A value going to be? So initial cost after 1 year is A sub 2. The N value is a little higher. So that means we're going to look at N sub 6. Again, we're having to add 1. I'm getting that pattern from that last statement. So if we depreciate at 15%, what does that mean that we have left? So if we lose 15%, that means what percent do we still have from 100%? Well, we only have 85% left. And just like we did in the previous examples, again, multiply that or move the decimal place over. That's going to be equal to 0.85. So our formula that we're going to have to use is A sub 6 equals, I actually have a typo in my key, so I'm having to redo this problem. 3250 or 500 times 0.85 raised to the N minus 1, which is 5. So 32,500 times 0.85 raised to the 5th power. I'm getting approximately 0.44375, and it keeps going. And again, I'm using a TI calculator, so all I'm going to do is hit times the 32,500, and I don't have to worry about typing in the whole decimal, and it keeps my answer really, really accurate. I'm still going to round off, though, because we're dealing with money, and so we're looking at $14,420.42. So in 6 years, that car is worth less than half of its original value, and that's a pretty good deal. So this is why, you know, buying a used car is not a bad thing, because in just the first few years of ownership, actually the first 2 or 3 years, you lose almost half the value of the car. So it's worth looking at used vehicles. Alrighty, last example, last word problem. Carla's Clothing Corner opened 8 years ago. The first year she made $3,000 in profit. Each year thereafter, her profits averaged 50% greater than the previous year. What was the total amount of profit she can project having earned after completing her 9th year? So are we looking for what she earns in the 9th year, or the sum of everything including that 9th year? We're looking for the sum on this one. So 9th year, we want N equals 9. Okay. First year, $3,000, so that's going to be A sub 1. If her profits are 50% greater than the previous year, here's when we need to do a little bit of math. So 50%, if I change that to a decimal, I get 0.5. But wait a second, if I multiply that by something, aren't I just going to get that same, I'm going to get half of the original value and have to add it back on. We'd have to do kind of this recursive formula thing, and I really don't want to have to do that. So to change this into more of an explicit situation, if we have to add that back on to the total of the previous value, that means what percent is everything? Well, that's 100. So here's a test. If I actually multiply it by 1.5, I use that as my R value, this is what happens. So let's say I started with $100 and I multiply that by 1.5. Well, 100 times 1.5 gives me 150, a 50% increase over the previous value. So 50% increase, you actually want to do 1.50 as your multiplier. So let's go ahead and add that up. So we're looking for S sub 9 equals, first year profit was 3,000. We're doing 1 minus 1.5 raised to the 9. Again, the 9 only goes to the 1.5 divided by 1 minus 1.5 in the denominator. So that's going to give us 3,000. 1 minus 1.5 raised to the 9th power, again, if you're careful typing it in, you can go all at one go, is going to give us a negative 37.4434 approximately, all divided by a negative 0.5. My negative values kind of cancel each other out. So we're really looking at 3,000 times 37.4434, all divided by 0.5, and we're going to get out a total of, excuse me, $224,660.16 total profit. So again, this is different than what you would get or what she got just that 9th year. If you calculate that out, you'd actually get $76,886.72, which is significantly lower than the sum of all those values. Alrighty, as always, let me know if you have any questions. Try out the extra practice problems that I have posted, and then let me know what you need to go over.